I'm going to be solving question 73 from the night textbook. This question is pretty wordy, but basically all it says is that we have this Otto cycle, which is modeled after the gasoline engine in a car. And it wants us to show that the work done by the cycle is equal to this equation given in the question. So first, by looking at the Otto cycle, we can see that from 1 to 2 and 3 to 4, that this is an isochoric process. And because of this, we know that there's going to be 0 work done. So we don't even have to factor that into our equation. And then from 2 to 3 and 1 to 4, those are considered an adiabatic process. So we know that the work done to the system for these processes will equal the change of the internal energy. So that will look like W12 is equal to delta E12. And just a quick word about the Carnot cycle and the Otto cycle. So basically the reason that we're going to use the Otto cycle is because it shows us 4 different temperatures, and it has heat addition and rejection over a range of temperatures. So this is the addition and this is the rejection. And so you can see that this is going to be over a range of temperatures of 1, 2, 3, and 4. Whereas the Carnot cycle is only over 2 temperatures, and they're constant. It's not over a range, it's just the temperatures, the same 2 temperatures every single time. Although the Carnot cycle is more efficient, the Otto cycle is a better model for an internal combustion engine like this one. So, continue on with the equation. So we know that it's equal to the change of the internal energy. So internal energy, as we know from the textbook, is NCV. And for this, we're going to use T2 and T1. So T2 minus T1. And then for the other cycle or other process, we're going to use W34 is equal to NCV, but this time we're going to use T4 minus T3. And we know CV is a specific heat for constant volume, and that the sum of the work done to the system is the negative of the net, which looks like this. Work net is equal to negative work of 34 minus work 12. And then we could just plug in these 2 values that we got above. So this is going to be negative NCV T4 minus T3 minus NCV T2 minus T1. And we could define Y as CP over CV because this is the ratio of specific heats in terms of degrees of freedom. So Y is CP over CV. And then from there we can simplify it even further to CP equals CV plus R. And once again, simplify to CV equals R over Y minus 1. And then from here, we're just going to substitute this into the equation above and simplify everything out. So we're going to get the net work is equal to N over R, or N times R over 1 minus Y times T4 minus T3 plus T2 minus T1. And as you can see from our 2 adiabatic processes, we got the net work, also known as the work going out of the system. And this equation is the same as the original equation given.